Hi and welcome to this video, which is hopefully going to demonstrate and explain some of the recent developments I've been working on, particularly to do with Industry Foundation Class or IFC Model Exchange from applications or software such as Grasshopper or Digital Project into Revit, where I've been developing an add-on to import some more sophisticated aspects and attributes of an IFC data file. I'm going to start with two models. The first is basically a massing or a form that we might like to try and get into Revit. It's a bit arbitrary, but it could be a building facade of some description. This particular shape is defined by three section curves and then a loft surface between the two, and Rhino and Revit both have a loft capability of the description of this type of shape, as does the Industry Foundation Class format. So we're going to use that as a bridge between the two software. In Grasshopper here, this model is set up parametrically. The inputs, as we've seen, or you might find looking at Grasshopper, could be spreadsheets, objects of geometry in Rhino documents or beyond, giving us some freedom to explore and assess different options and variations of a theme on what the actual shape or form might be. The Grasshopper definition contains a number of native Grasshopper components and then some of the geometry gym building information modeling components that are specially written to generate IFC data and send that across to a file that could be used in a viewer or in any other BIM software. So here's effectively a section spine shape representation, which is then being said it represents a building. So when we want to actually happy with the form and shape that we've got, we can use the SSI bake button to actually save this data out to a file. Now normally we could actually open that model in a viewer like Solibri or DDS, but they haven't had much success yet with this particular shape representation. There is an IFC importer that I've also done for Rhino as part of this development, so we can also open it and check the shape or form here in the Rhino environment. Note that actually this file is quite an efficient shape representation. Not typical IFC files have meshed this sort of shape to transfer it, particularly for coordination or something like that. This file is about 5 kilobytes, whereas I'd expect if it was a meshed representation to some sort of acceptable tolerance, it would be a couple of megabytes probably. But here we can do it in probably about 100 lines of IFC data, defining, say, an arc cross-section curve, and then the orientations and the fact the section spine or loft exists for that particular shape. Now to try and open or use that shape now in Revit, if you've installed my add-on, and again these files and a link to from the associated blog post, then I can call on my add-on and then locate that IFC file and have it generate the equivalent data and attributes within the Revit environment. So I'm going to open it here. It's going to create a massing family object. At the moment I've still had some problems with inserting that actual family object into Revit, but it will create a family we'll have a look at. There's some initial options which soon will be expanded and enhanced further for controlling what actually gets generated and how. And also we'll be looking soon at model synchronization, so not just a once-off import, but actually updating previous versions and generations of that object. So at the moment that object hasn't been added into this Revit project, but you will see that the family is being created, so we could actually import that in, and soon I'll get that working so that it actually can be added as an object into the Revit project. So again, this is a lofted family element, and again you could edit it the same as if any other way of family creation could have occurred. The second example that I want to have a look at is perhaps a massing tower project comprising perhaps some typical slab objects which might have been generated in Grasshopper. Again, there could be actually some spreadsheet driven generation of this object and some recording or attribute assessments in terms of floor areas, facade areas, etc., but this still is a fairly simple example just to demonstrate this process or key. So here I'm actually using some Grasshopper graph objects, so I can actually play around with the controls, including the offset between the two sets of plates and then the actual diameter of the plate as it goes up through the height or extent of the tower. So that's all controlling downstream output, which is then generating a slab. Again, the building's floor-to-floor height is controlled within this actual definition. It also includes effectively the equivalent of a Revit family, so it's actually specifying a slab type and then using that to generate the thickness and each slab object associated with each building story level. So again, I can, when I'm happy and want in a state to actually send the model to Revit, then I can bake that to an IFC file, and then I can come back to Revit and again import that model data in. So as I mentioned before, what I would next be looking at is also then if existing objects are in the Revit model, and then having them update, including hopefully retaining any of the attributes or element associated editing that might have occurred natively in the Revit environment since the original objects were created. So each of these objects actually is a slab element in the Revit project, and you will see that a family has been created from the data within that Grasshopper definition. It will use existing families of the same name if they exist. And it is a native Revit object, so if we actually want to select the slab and edit its boundary, then we could actually do that in the same as if it had been created manually or any other process. So here, if I want to change the radius of the slab perimeter, then it can be edited and updated as per normal use. And again, the brilliant part of Grasshopper is that you can quickly evaluate and check and assess very different options and arrangements. So if I want to look at the next scheme or generation or option for this project, I can change the tower profile quite dramatically and very quickly then exchange and update that information into the Revit file. Again, the file size here is only 200 kilobytes, which is pretty good for containing a reasonable amount of data. So I hope this is interesting and helps explain a little bit more about the development. These files are available on the blog, so you can download them and test them for yourselves, and I look forward to getting feedback. There's certainly lots of work and potential and lots of improvements that I certainly plan to implement, and certainly they will be driven by user requests and demands and real project use.